The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon. This is Melissa Lapsa from Oak Ridge National Laboratory, and I'm very happy to welcome you to our Envelope Technology Research Team webinar on energy savings impact of airtightness in U.S. commercial buildings. Next slide, please. All of our lines are muted at this time, so if we would encourage you, if you have questions, to add them into your question panel and submit them throughout the presentation, and then at the end, we will address those as we have time. And if we don't have enough time at the end, because we have a full schedule here of excellent presenters, we will follow up with you on email. So I'll give a quick introduction to each of our great speakers today. From the ORNL side, we have Dr. Deanna Hun, and Deanna works as an R&D staff member at ORNL. Her research areas include improving the airtightness of buildings while minimizing risk due to potential building material deterioration and indoor air quality problems. And she's investigating the integration of the latest developments in materials and manufacturing into building envelopes. Also, we have Dr. Mahabir Bhandari. He's also an R&D staff member at ORNL. He has more than 20 years of experience in the field of building energy performance. In recent years, his focus has been on fenestration research, whole building energy simulation, manual and auto calibration, industrial energy data analysis, and combined heat and power. And after we hear from the ORNL speakers, we're going to hear from a Better Buildings partner from Arlington County, Virginia, and we're going to hear from Jessica Abralind from Arlington County. And Jessica has 14 years of experience in sustainability. For the past 9 years, she has served as a green building planner for Arlington County, Virginia, facilitating the development of green buildings in Arlington. She coordinates a variety of stakeholders, including business leaders, environmental experts, and advocates, residents, and political leaders to develop, assess, and implement the Arlington's Green Building Program. We also have Philip Agee from Viridiant, and he serves as the technical director of the company. He has 10+ years of fieldwork, design, consulting, building diagnostics, analytics, and research experience in the built environment. Agee has published and presented his work on the human factors of human-building interaction, zero-energy housing, and applied building science topics at national and international conferences. In the context of ENCLOSURE expertise, Mr. Agee has contributed to the refinement of building performance standards through repeatable testing, including ASTM E1827 and ASTM E779. And we also have Caroline Hazard on the line, who's going to facilitate running our poll questions. Next slide, please.
Great.
So,
thank
Caroline,
you, Melissa.
take it away.
Yeah, thank you. This is Caroline, and I'm going to read the question here for you all. We'd like to know who's on the line so we can get a better sense of how to go through our information here. So if you can type in which type of organization best describes you or your organization. Are you a building owner or manager, or an architect, engineer, manufacturer, energy service providers, or somebody from research and academia? And if we haven't listed your organization, go ahead and type that into the chat field and we'll capture that as well. So this really helps us understand the breadth of the types of folks that are out there. So Megan, if you want to go ahead and run the poll, that would be great. We really appreciate it. We'll take a few minutes here minute or so to get the responses in. Doing pretty good here. Wait a few more seconds. Okay, let's see what we got here. So we have a pretty good dispersion of folks. We've got quite a few architects and engineers at the highest count of 31%, but then we also have a pretty close follow-up there with manufacturers. So we really appreciate everybody who's on the line, and feel free to ask questions at any time. So let's go ahead and let Melissa do a little bit of an introduction here to the Envelope research team.
Thanks, Caroline. Okay, so what is our Building Envelope Technology Research Team? Basically, we're here, our Oak Ridge National Lab team is here to connect Better Buildings partners with advanced building envelope technology solutions. So we want to be able to provide resources that can help make informed decisions for cost-effective envelope solutions. And we do this through verification studies, specification documents, case studies, fact sheets, calculators, and analytical tools. And these are available on our website, and we'll show the URL there at the end of the presentation. Next slide, please. So we have a very diverse team of partners involved, and on the next two slides, we can move to those. I'll show you who's involved right now, who's a member of our team. So our members include building owners, managers, property managers, A&E firms, and construction and installers. And the next slide shows our friends, and these are researchers, academics, trade associations, energy service providers, manufacturers, and other subject matter experts. So I'd encourage all of you to get engaged with our team, and we would love to share information, best practices with you, and love to hear from you on your experiences and help us provide more up-to-date new information on our website and get you involved with some of the research that we're doing on commercial building envelope solutions. And now we have another poll, I believe.
Yeah, why don't we go ahead to the next slide, Megan, and I'll read the poll question. So the focus of today's webinar is on air leakage testing. And so we want to get a sense of how familiar or experienced you are with air leakage testing in commercial buildings. And so, you know, if you have no or little experience, this is all new to you, you want to kind of check that box. If you have some experience, you've maybe worked with it a bit, but you don't feel like you're a super duper expert, you don't do it all the time, that's what you want to check. Or maybe very experienced, which means you have it required for your building, or it's something you do every day or all the time, or perhaps it's other, and you'd like to share your response there. So let's go ahead and run that poll so we just get a sense of our audience. And I do see some folks typing into the questions field, so that's great. Why don't we go ahead and close the poll, Megan? And it looks like we have folks right at that, that early stage beginning to understand things, some experience, and that's great. We'd love to hear any thoughts and your questions about that experience. But we also do have some newbies here, so that's good too, and really appreciate your feedback. So why don't we go ahead and get started with Mahabir and Diana. Go ahead to the next slide. Thank you.
Hi, this is Diana Hun, and I am with Oak Ridge National Lab, and today I'm just going to give you a brief update on the work that we have been conducting on air tightness in commercial building envelopes. And Mahabir Bhandari will present the second half of this slide deck. Next slide, please. So this slide here just gives you a very quick overview of why we care about air leakage. And in the pie chart are shown the how the different components of the building envelope affect energy consumption in commercial buildings. And as you can see, air leakage accounts for about 20%, which is somewhat comparable to the contribution from conduction through walls and conduction through windows. And even though air leakage, as you can see, is a pretty high contributor, currently blower door tests or whole building air leakage rate tests are not mandated in most of the US. Next slide. So here, this table summarizes what is currently the lay of the land with regard to blower door tests. As you can see on the first section here on the table, in most of the cities and states in the US, conducting a blower door test is optional, okay? But there are some exceptions, as you can see, with regard to Seattle, Washington State and New York City, where they have made a blower door test mandatory, but meeting an air leakage rate here is optional. And the logic behind this was that they wanted to give the construction industry time to get familiar with this type of evaluation or the blower door test. And currently, some of them are working to try now to make these leakage rates mandatory now that the construction industry have become more savvy about these testing methods. Now, there are some agencies like GSA and the U.S. Army Corps that are mandating the air leakage test and also have specific air leakage rates that need to be met. And in general, owners of private buildings will conduct the blower door test if they're trying to meet some sort of certification, such as the one from the USGBC. Now, if we go back to what most of the cities and states are currently doing, I mentioned that the blower door test is optional. Next slide. So in those cases where, again, the whole building test is optional, the other methods that they can comply with are by doing tests at the material level, that is like what is shown on the left-hand side of this picture, or they can do an assembly test like what is shown on the right-hand side of the slide. And again, these are laboratory tests where you're just primarily evaluating the air barrier material. Next slide. In contrast, the blower door test, as some of you are familiar with, will evaluate the performance of the air barrier system once it has been installed in the building envelope. Next slide. So what we did last year is we talked to a certain number of stakeholders, you know, just to figure out or have an idea or get some input about what were your thoughts, what were their thoughts about this type of evaluation. Next slide. And so we grouped them into several bins, and here's some of the information that we gathered from the owners of privately owned buildings. In general, they seem somewhat reluctant to do these tests because the tenants are usually the ones that pay the utility bills, and them as the owner may not get a higher rent from, if their tenants pay for the, if their tenants then pay lower utility bills. Also, what the owners mentioned to us is that when the tenants are looking for rental space, the utility bill is usually not one of their top priorities. And this is likely because the cost of the rental space is much higher than, again, that of the utility bill. And another reason why they don't pay a lot of attention to these types of evaluations is because many of them don't keep their buildings for more than 10 years. Next slide. So we talked also to a few representatives from the construction industry, and they seem, some of them, reluctant to embrace these because of the cost of the test. Also, they were worried about potential shutdown time to conduct the test. But what we gather from the blower door test consultants is that they can do these evaluations at night or during the weekends so that they don't alter the construction time. And another reason why some contractors are reluctant is because of potential delays if, you know, a problem is identified, and then they need also then to fix it. But as I mentioned previously, one way to solve this problem is to follow what Seattle did, in which they started with these tests as mandatory, but the airtightness rate is optional. And again, this gives time to the construction industry to get familiar with these evaluations and also how to improve the building envelope accordingly. Next slide. And also we chatted with some blower door test consultants, And what we found out was that their availability varies around the country based on the demand. In other words, cities where the blower door test is required, in those cities you will find more consultants. And this, very roughly, the amount of time that it could take you to, let's say, conduct a test in a 35,000 square foot building could take somewhere around 10 hours, but this will vary depending on the complexity of the building. And as I mentioned earlier, they can conduct these tests at night or during weekends, you know, to accommodate occupancy or construction schedules. And what we also found out was that there is currently not a certification program for the blower door test consultants. However, those who we talked to were mostly in favor of them. And they suggested that perhaps, you know, only one of the team members that went to the site needed the certification instead of the entire team in order to decrease costs. Next slide. And they also provided some suggestions on how to decrease the cost of the test and also the execution time. One of the recommendations was that currently the test is conducted both in the pressurization and depressurization, but perhaps just doing one of these two could be sufficient. Also, it could save time if either a blower door consultant or an envelope consultant got involved early in the project so that they could potentially identify problems in the building envelope before they spread throughout the whole building. They also said there could be improvements in the equipment, such as using wireless pressure gauges if they were available, or if larger blower door fans are available. This could also help decrease installation time and dismantling time. And lastly, they mentioned that if the buildings had more effective mechanical dampers, this could be helpful. Otherwise, as you can see in the pictures in the bottom, they have to go around taping all these vents or covering them before they can conduct the test. Next slide. And lastly, what I'm showing here gives you an idea on how much a blower door test could cost. So Hart and his colleagues came up with this graph that is shown on the left based on input that they got from blower door test consultants. And as you can see, the cost per square foot is higher the smaller your building is, which makes sense. And on the table on the right-hand side now, it puts this graph into actual values here. So in summary, I mean, a building that is 10,000 square feet or smaller in this type of building, the blower door test cost would be about less than $5,000. And if you had a building that is that has a floor area of 100,000 square foot or less, the blower door test will be less than $10,000. But keep in mind that these will vary significantly with the complexity of the building envelope and also with the distance that the consultant has to travel from the building site to where they are located, because now you have to include now the amount of time that the consultant will have to travel and the shipping of all the equipment. Next slide. Mahabir, you're next.
Hello everyone, my name is Mahabir Bhandari and I'll be presenting results of a simulation study we conducted to estimate the national energy saving potential of increased air tightness. Next slide please. So for this study, we selected 7 commercial building prototype models for this study. And the graph at the right shows the buildings selected in the filled bars. So these 7 buildings represent like more than 55% of the total commercial building floor area in the United States. So we limited ourselves to these 7 only for now. And we use 3 different infiltration rates. So 1.07 CFM per square foot, which is based on the study NIST conducted of 386 commercial buildings around the country. And 0.4 CFM per square foot was optional in building codes, as Deanna mentioned earlier, and also 0.25 because mandated by Army Corps of Engineers. So we just wanted to see what would be impact if we reduce from base case to these two infiltration rates. And the buildings were simulated for representative cities in each of the 16 DOE climate, ASHRAE climate zone, and you can see those that are listed in that small table at the bottom. So generally, in simulation, the fixture infiltration rates are used when they simulate using Energy Plus or other models, but we use the detailed hourly infiltration rate that were calculated by CONT, which is whole building airflow modeling tool by NIST. So that accurately, you can accurately input the hourly infiltration rates in Energy Plus software. And based on that, we predicted energy savings by simulating all these 7 buildings in 16 climatic locations and for these 3 infiltration rates. And then the Energy Plus predicted savings due to reduced infiltration rates were then multiplied by the weighted building areas for each building type in a particular climate zone. So for example, the per square foot savings for retail buildings in Chicago, we took that and then multiplied it by the total retail building floor area in climate zone 5A. And the national savings potential was then aggregated for all 7 building types. Next slide, please. So here are the results that show the predicted. So we converted it to source energy savings so that we can add both electricity and gas consumption. And we used 2.99 for the source to site to source for electrical and electricity, and 1.15 for natural gas. And these predicted savings are, we have 238 trillion BTUs when we reduced air tightness from 1.07 to 0.4 CFM per square foot, and 284 trillion BTU when the air tightness was reduced to 0.25 CFM per square foot. And on the right side on the upper graph, you can see that the standalone retail has the highest energy savings potential and amongst all the building types. So even though the retail buildings, there's a small table on the right corner, so it says a smaller building, only 25,000 square foot. But because it's a 1-story, it has more surface to volume ratio. And also the retail buildings are the larger, like they are 15% of all commercial building floor area. So that makes it different even if it's a small building, but that's had the large saving potential. Similarly with the climate zones, 5A shows the highest potential, almost 90 trillion BTUs. Next slide, please. So just talk about that, and we have a detailed report. We can send it later, or we are presenting that paper at the buildings conference. But I just wanted to quickly go over, there's a easy web-based tool here. So I want to introduce that tool so that you can use this and to find out the energy and cost saving potential from improvement of tightness. So this tool is developed by ORNL, ABA, and NIST. And it uses, again, the same DOE prototype buildings, and user just need to input that location and type of buildings and square footage. Then you can say what is your base infiltration rate or leakage rate, and then what is your target. You could also put electricity and gas cost part of that. And next slide, please. So this slide shows the results screen for the tool. So it shows the predicted annual electric and gas along with the cost savings. And then the latest version, which is to be published, also shows the moisture transfer into the space due to their leakage rate. So this is in continuous development. Please feel free to use it and send us your feedback, and we'll be happy to include those things. So that's all from me. Thank you.
Great, thanks, Mahabir. So we'll turn it over to Philip and Jessica now.
Great. Thanks so much for having us. My name's Philip Agee. I'm the technical director of Viridiant, and my colleague Jessica Abralind from Arlington County are going to talk a little bit about commercial enclosure testing and a case study project that we are currently working on. Next slide, please. So, as I mentioned, my name is Philip. I'm the technical director of Viridiant. Most kind of forming our perspective on commercial enclosures, most of my experience kind of comes from the Earthcraft Light Commercial program, which I'll talk a little bit about in the future of the presentation, kind of ASHRAE level commercial audits, and supporting the Department of Energy's Advanced Commercial Building Initiative through some work with the South Face Energy Institute in Atlanta, Georgia.
Hey everyone, this is Jessica Abralind. I work for Arlington, Virginia on their green building program. And I'm going to be talking today about the owner's perspective and share a little bit of why we did a building enclosure test on our solid waste building that is currently in the design phase for renovation. Next slide, please. So the origin of why we decided to pursue building enclosure tests actually starts back about 1.5 years ago when we started to update our facility sustainability policy, and that's how that's a policy we use to build our own county facilities, our libraries and community centers and public office buildings. And in that process, we came to the conclusion to focus more on the building enclosure strategies like passive energy strategies like insulation, air sealing, and our policy, we included Earthcraft Light Commercial that Philip alluded to because it fits our smaller buildings that we have better, and it also includes a blower door test and air leakage performance standards to hit some of those passive strategies and energy targets. So one important part of that sustainability policy update is that we pulled together an interdepartmental working group that included our facilities maintenance department, our facilities design and construction department, our parks department, fire, housing, code inspections, and that was a really effective way to do this policy, which we completed last fall. And the reason why I'm talking about that today is because our facilities maintenance department was included in that policy, they came to us with, to me and my colleagues on our energy team with this renovation that they were planning of the solid waste building, and wanted to see what we could do to incorporate some of those more passive energy saving strategies into this renovation. The reason that we're really focusing on the building enclosure test and the building enclosure overall is, first of all, that we're focused on energy and our own internal greenhouse gas reduction goals. We're also going to be owning the building for a number of years, and so we'll pay our own energy bills and we'll see cost savings through those energy savings. And really importantly, the occupant comfort and health improvement that comes from focusing on the building envelope and reducing drafts for folks that are working in the building. So the solid waste building, this is the first time that we're trying out Earthcraft Light Commercial, and it's the first time that we at the county have done a blower door test and pre-construction occupancy survey to inform the design. One of the challenges that we had is that our design team was already engaged in starting to design the renovation before we brought in Earthcraft Light Commercial and the testing standards that we wanted to pursue. So that was not in the original scope of work, and we had to do a little bit of moving around to accommodate that in the budget. So with that, I'm going to hand it over to Philip to talk a little bit more about the building and the test that was done.
Great. Thanks so much, Jessica. Next slide, please. So just a few definitions to cover, because one, you might hear me cover a couple technical terms, and just for folks in the audience, two I want to highlight is you'll hear me maybe talk about the enclosure as being part of any building that physically separates the exterior environment from the interior environment. So it's really what we're testing with the enclosure test, what's inside and what's outside of the building. And then the last kind of definition there that I will take the time to read, because it's kind of a lot of the context for why we did the test, was the nonprofit organization I work with facilitates a regional green building program that was developed by the South-Based Energy Institute called Earthcraft Light Commercial. And so it's a regional green building certification for small commercial buildings, and we define small commercial buildings as 50,000 square feet or less. Next slide, please. So why commercial enclosures? So part of the Earthcraft kind of program ethos is we like to measure whatever we can, particularly when it comes to enclosures, to just validate kind of the prescriptive processes that we have designers and teams undergo when we do, visual inspections and things like that. So it just helps to, quantify what our hard work has, how it's paid off. We're focused on this commercial space of about 50,000 square feet or less because of the variety and volume of those spaces. And when I mean variety and volume is, think about the variety of commercial spaces that are 50,000 square feet or less. Probably most of us maybe listening to the webinar in our office. You may have gotten coffee at a small commercial building. You may go to an after work program tonight at a small commercial building. And then also on the volume, this sector of the commercial market represents greater than 80% of the commercial market. So it's one that is has a big impact on on energy consumption and people in general. And so we've been doing a lot of measurement in this building type, not only on the enclosure side, but on outcomes related to energy use, water use, occupant experiences in the building. And so we're excited to talk a little bit more about this specific project that we've been working on with Arlington County here. Next slide, please. So we performed an assessment on the building that we're going to be talking about for this case study in November, and kind of the high-level assessment methods. We use multiple methods, and the enclosure testing was certainly one of them, but we also did a thermal comfort survey, field observations and thermal imaging, and then benchmark the energy use in the building. And we like to use multiple methods, just like as kind of multiple tools in a tool belt for us to approach solving problems in buildings, whether they're going through a new design or for a new construction project or renovating an existing building. Next slide, please. So just characterizing the site in the building context, a couple tables here for you to think about. So the building's approximately 15,000 square feet. It has a highly dynamic occupancy load because they have folks, this is used for their trash and waste service. So they have a lot of employees that come in the morning to get out which trash routes they're going to go on, and then they leave the building. So highly dynamic occupancy load. In any building performance or any type of approach to creating better buildings, we always have to think about the context of the location of the building. So we're located in a mixed humid climate zone here in Arlington, in climate zone 4A, and we want to kind of frame the conversation around this what the building is used for and where it's located first and foremost. Next slide, please. Okay, so as Jessica alluded to, one of the things that we wanted to bring into our assessment approach was a thermal comfort survey. So we used the ASHRAE 55. Kind of had in the appendix, there's a 2-page survey that has a combination of Likert scale and multiple choice questions that actually we ask employees of this building and staff members to take some time to spend with us and describe their comfort experiences and perceptions in the building. And so a couple of things that we learned were that the majority of the folks work around the perimeter of the building, and that makes sense for natural lighting and things like that. But it also, if you see this chart here, we understand and we're able to find that generally folks are pretty dissatisfied with their comfort. It's an uninsulated concrete block building, and there's a lot of thermal discomfort. And so you might say, well, why are we talking about this in the context of a commercial enclosure improvement? And so we always like to kind of put the person first in the center of the problem space, and sometimes we have to remind ourselves that buildings are for people, and so typically if we are able to solve these comfort problems, we're doing it through means and methods that reduce energy use, improve building durability. And also users of buildings are very rich sources of data that should not be ignored, and people feel empowered and part of the process when they are informed and feel like they have a voice to contribute to the potential of a renovation. So then we use this information, provide it back to the design team, and it helps them, in the challenge of designing on systems or air sealing strategies, what might have the biggest impact on people and energy and durability and so forth. Next slide, please. So of course we did execute an enclosure test. This is kind of a layout on the right here of the building, the orange dash line being the boundary of what we were testing, the office space. The garage we did not include in the test boundary, one, because they typically have the garage door open and it's not really a heated space, so we left that area open to the outside. So we're really just measuring the enclosure, that boundary condition between what you see there on the orange dotted line. You'll see green hoses. We use those for reference pressures, just so we can ensure that, one, we're able to use the equipment to effectively tell us the pressure difference between inside and outside of the building. And let's see here. Another thing that we did for the test plan is just, where are we going to set up? There's a lot of pre-planning that goes into how to execute the test. I will say that, it takes 3 or 4 hours of prep for the test. To Deanna's point earlier, we did come in at about 4 o'clock in the afternoon because we didn't want to disrupt operations in the building. And then I think we wrapped up around 9 o'clock or so. So, we had 4 staff members, approximately 5 hours. So about 20 hours on site to execute, the test and the observations that we're going to show you here coming up on the next slide. So here are the enclosure test results. Effectively, we used the U.S. Army Corps of Engineers testing method. We did depressurize the building. So kind of, we measure the leakage through the enclosure and at different increments, walking all the way, starting 75 down to 25 pascals. And here on the table on the right, you can see the results. And so our envelope leakage ratio is right at 1.03, which, is very leaky. For the renovation, we're going to be targeting a significant reduction, or, an ELR 75 of 0.40. So that'll be pretty significant. But, one thing that's important to note is now, most mechanical designs, as we're doing load analysis on buildings, most of the load designs they're just making assumptions about what the leakiness of the enclosure is. So, adding some information to this area can help us reduce the risk of oversizing equipment. So we're just, adding information into the problem to help reduce the risk of problems down the road. So next slide, please. So as we depressurized the building, we walked around with team members and kind of, observed what was going on in the building. We used some thermal imaging just to identify some areas that we could address in the retrofit. These series of pictures here are really present and kind of indicative of the kind of construction type. It's a block CMU wall that goes up here to this kind of K-joist and concrete steel pan intersection. And so everywhere, the dark color kind of signifies, that we're depressurizing, so cold air is coming into the building at that intersection. So it helps, the design team understand, okay, this is an area when we're retrofitting that we need to make sure that we have a plan and a detail to reduce air infiltration at that point. Next slide. So we also, in the test prep, we had to get up on the roof, and we have, of course, lots of unintentional holes, but we do have 13 intentional holes in the enclosure, mostly through, both passive and active vent penetrations. So they were sealed for the test, and you can see a sealant there on the bottom left. But then even during the enclosure test, you can see on the right there in the thermal image that, even though the vent is sealed off, we still have some leakage occurring around that intersection, probably between the roof deck and where the piece of ductwork actually penetrates. So just more visualization for the team to help consider as far as going through and making adjustments. And the last thing I'll note is, if we had, we could, on the test out in the back end of the project, we have the ability to now kind of test the dampers that are there by untaping and taping some of these ventilation penetrations. Next slide, please. Okay, so that kind of covers, the case study, some common kind of enclosure opportunities that we've seen, having done this for a few years. Just wire penetrations that we see commonly, not sealed, even in new buildings, lighting fixtures, duct to boot penetrations and exhaust ducts are a lot. A lot of times it's intersections, it's details between one part of the building and another, like you see here in this photo on the right, where we have fog leaking out of the soffit vent here. That's a photo from my buddy Mike Barsick down at South Base. Next slide. So this is, can lights are very common. These are actually buildings here that were built within the last 8 or 9 years. So, we can see the light down through there. So we know that that's, we have a bypass, and, air will transfer through that space, with no problem. Next slide. And this is just the kind of reverse view of that, or looking at it from inside the building. So if you were to walk around the building after this webinar that you're in and count how many can lights that you're going to see, it's likely that you have penetrations like this kind of throughout the building, and very common. Next slide, please. And this is more common type penetrations that we see, and opportunities to seal with kind of an air impermeable material like foam, caulk, backer rod, or sheathing. The left image is kind of the intersection of a top plate there with drywall, and of course it's right there at insulation. So the insulation is less effective because we have air infiltration, exfiltration happening. On the right we have mechanical plenum penetration that could just be sealed off there. And a lot of these benefits in comfort, also durability, reduced dust, improved indoor air quality. So we always look for compounding benefits in talking with owners about why it's important to integrate, good detailing to execute these types of details there. All right, next slide. More penetrations, right? This is a new building built probably within the last 4 or 5 years. So you can probably, again, walk around and you see the conduit on the picture on the right was sealed, but the mechanical penetration wasn't. This is all in the same room here. The penetrations on the left side over here are obviously not, but, so part of it is just who is responsible for that in the contract documents. And typically we find that is not covered in contract documents. So we try to make sure that those items are covered. Next slide. So just a couple lessons learned from some other tests that we've been doing like this. And, one is someone needs to manage the ventilation systems, be able to find them, be able to turn them on or off. Most commercial buildings, the ventilation is designed to operate at least, whether 24 hours a day or while the buildings are occupied. Commercial door assemblies are kind of a pain in the butt. They're not like residential door assemblies. They have automatic openers and they're larger openers. Make sure you record the building conditions before testing, and bring extra everything: fans, trash bags, tape, extension cords. This work can be a lot of fun, but it is also challenging if we don't have everything that we need there. So next slide. And so, a little bit, further lessons learned is, having a plan really helps. Pre-test meeting, what equipment's being brought, who's doing what. Handheld radios are fun. Make sure you use only one fan per circuit, or you'll have issues with circuits overloading, which we actually had that problem at our case study project. And we like to do these interzonal yellow hoses. So like places like stairways and, places that are not fully connected by the building, we can measure to make sure we're depressurizing equally. I think next slide. And a couple, we like to bring a projector and project it up on the screen, so people aren't just like kind of leaning over your shoulder, because this work is fun, and we also often have facility managers or general contractor designer that participates, and we certainly welcome that. So it's kind of, a lot of work goes into it, so we want to show off, the fun part of it. Next slide. And then why do we do all this is we like to use, what measure gets managed, and particularly as it relates to enclosure tightness, we have a lot of uncertainty about elements of the design, but by doing an enclosure test, you can really move it from the uncertainty category into the risk category. And, risk can be managed and uncertainty cannot be managed. So we see benefits for it. And I think that might be my last slide. Oh. A little continued reading if anybody has a hard time falling asleep. This was some work that came out of that Advanced Commercial Building Initiative that was supported by DOE and Southface, where they actually looked at measuring. They went out and did a commercial enclosure test and then did some different air sealing measure strategies and modeled what the percentage savings would be. So if you're interested in reading further, this is a great ASHRAE paper that's available. I think Mahabir said you can get it on ResearchGate, download it for free. And I think with that, that's it. That's our last slide. I think we might have one more.
Thank you so much.
Yeah, thanks so much.
Excellent. Okay,
Great.
Caroline, I'll turn it over to you for the Q&A.
Sure, yeah. And if you have any questions, go ahead and type those into your chat window. And let's get started with some of those. So I'm going to go back in time a little here. Deanna and Mahabir, we got a question in during your presentations. Do you have any field verified results of energy savings from air sealing?
Yes, Carolyn. In fact, we are currently evaluating some retrofits, some buildings that are being retrofitted, and we are collecting air leakage rates before and after the envelope has been renovated in order to then use this information in simulation models to estimate the potential energy savings. And we hope to be able to make this data public sometime this summer.
Great, appreciate that. And if Gina from New York City is available, we've unmuted your line. I understand you have some updates for some of the New York City policies around air leakage testing. Gina, can you hear us? Are you there? Gina may have stepped away from her desk. So, so we don't get any feedback. Why don't we go ahead and put that back on mute? But she did update us that the requirements in New York City are mandatory. So it's not optional. So that's great feedback. We really appreciate the update, and that's helpful to our research here. So another question for Mahabir and Deanna. What was the moisture infiltration from the Oak Ridge online tool?
Yeah, so this is Caroline, this is a new feature in the calculator. So the calculator estimates the moisture that's introduced into the building with air leakage, and it is calculated in the tool or Energy Plus from the mass flow rate of air and humidity ratio.
So just to backpedal a little on that, Caroline, to give the audience a little bit more background, ORNL and NIST and the Air Barrier Association of America put together a calculator that estimates the potential energy savings from improvements in air tightness. And this calculator is free and it is online. If you go to the ABA website, you'll find it there. And as Mahabir mentioned, we are adding these extra features to the calculator. We have a beta, it's at the beta stage right now, and it should be available to the public soon.
Great. Appreciate that. And so, Philip, I believe this question came in during your presentation. Could you help us with, when you're referencing square feet, is that square feet of enclosure or floor area? I'm not sure exactly which slide that came in on, so hopefully you're able to speak to that.
Yeah, great question. So just to clarify, I said that I described both. In earlier slide, I described the building being approximately 15,000 square feet of conditioned floor area. The analysis for developing the envelope leakage ratio was based on a square footage of the building envelope. So if we think of it as a simple 6-sided box with 4 walls and then a ceiling and a floor. It would encompass that entire square footage.
Okay, great. That's great clarification. And another question that came in during your presentation, Philip, where does the greatest air infiltration, exfiltration tend to occur with existing commercial buildings? And what available technologies offer the greatest potential for significant reductions in air infiltration or exfiltration? I suppose the Oak Ridge team might have thoughts on this too, but I'll let you go first, Philip.
Yeah, so based off of the experiences that we have, and we've tested buildings that were built that are, part of it, the response to the question has to be based off of when the buildings were constructed, because we have different materials and different means and methods in the buildings. But one commonality that we see is we have a lot of leakage around dampers and ventilation systems. And then even I had a slide that I took out just due to time, but even intentional holes that we have in a building, like doors, and you might see a commercial doors come together where there's actually a gap. So there's no shortage of leakage opportunities as far as technologies to, there are, just like most technologies and systems, there are inexpensive ways and more expensive ways, not to be general or be silly, but there are basic air sealing technologies, and now we're seeing more type aerosol based products to do air sealing. So a lot of it's just dependent on budget, scope, and need.
Great. And Mahabir or Deanna, do you have anything to add, or?
Not necessarily. I agree with the previously mentioned comments. Yeah, so one thing I could add is that in general, you will the common leakage points is where there's an interface or a joint, let's say from the opaque wall to a window. Those are, typical areas where you will find, air leakage.
Right. Okay. And then I think this is also, let's start with Philip here, but it's focused on the Southeast, but again, Oak Ridge, you might have some thoughts. The question is, can you speak a little bit about moisture management benefits? In the Southeast, I see moisture associated with leaky buildings. People seem to care more about that than the energy benefit. How much does moisture play in? Go ahead.
So as an engineer, having an engineering background, we like to define what the boundary conditions are so we can then adjust and adapt and control, what's inside of our boundary. So at the simplest form, having the test done on a commercial enclosure and doing nice detailing for air sealing, that allows us to have a robust boundary that we can, so then we can adapt the indoor environmental conditions for the occupant, and we know what those ranges of performance are that need to work well. And this kind of ties into the previous question too, as it relates to the Southeast. You don't necessarily, we obviously advocate for enclosure testing, but you can typically detect some type of enclosure leak in a building if you see spider webs, because typically spider webs are set up as filter feeders. They're lazy like me, and so if you detect some spider webs in an area of a building, it might be worth investigating. But back, as it relates to moisture, there's certainly benefits from controlling the boundary, i.e. the enclosure, and then again to the point of the mechanical sizing of equipment. Right now, if you were to ask a room of mechanical engineers, they're making big assumptions on the equipment loads in the buildings if they're not doing this type of test, or they're not, so that creates, shorter duty cycles depending on the equipment that you have, makes more reliance on larger dehumidification systems. So, I think there's certainly several benefits from controlling the boundary. Great
comments there. We have another question in on just one more question, Melissa, and then we'll go to you. Does spray foam do a good job of sealing air leaks? I'll give that to all three of you.
Yeah, so I'll take at least the first bad of it. It can in the right applicator's hand with the right detailing. So I think that the what we're really talking about is I've seen really good spray foam applications and I've seen really poor ones. I've seen really good fiberglass insulation with caulk air sealing and I've seen really bad ones. So I put less focus on the material by itself, isolated in space, and more focus on the air barrier as a system. Which may comprise multiple materials and multiple subsystems.
Excellent. Really appreciate that feedback. So why don't we go ahead and close things out? We've got a few minutes here. Melissa, would you like to wrap things up? Can you advance the slides, Megan?
If we could advance the slide. I wanted to show our website address there at the bottom, and you'll see through that middle image, or the images that are along the bottom, that our website's organized by windows, walls, and roofs for our envelope systems. And then we've got a whole bunch of resources linked for each area, and we welcome your feedback on that. If you find it useful or something that you're looking for that's not there, just let us know. Next slide, please. And finally, I would encourage all of you to take a look at that website and consider joining our Envelope Tech Research team as a member or a friend. You can also get it as a member. You can get engaged with our research activities. As we talked about, we are looking at airtightness, and also we're looking at a building enclosure performance metric this fiscal year. And we've had a webinar on that, and there'll be more coming on that research. So would welcome your engagement. And next slide, please. We will be posting the webinar slides online. I want to thank all of our presenters and all of our participants today. And if anyone has any further questions or follow-up from the webinar, they can feel free to contact me at the ORNL email address listed there. So with that, Caroline, any final remarks before we close the webinar?
No, just a thank you to everybody. We really appreciate all the questions that came in. I did try and call through all of them. If we did not reach your question, we will certainly follow up with you offline, and we hope to see you become a member of the team. Thank you.
Great. Thanks, everyone. Have a great afternoon.
Bye-bye.